Between these three switches, we are going to have frame relay PVCs. The frame relay, the tunnel, is called as PVC.
Okay.
It's called permanent virtual circuit. PVC. All right. Permanent virtual circuit. PVC. We are going to form a tunnel between these routers. And to identify the tunnel endpoints, we are not going to use IP address or MAC address. We are going to use a special address type called DLC number. DLCI.
DLCI, right? DLCI.
Yeah, data link connection identifier. DLC. DLCI. Data link is layer 2, no? This is layer 2 technology actually.
Yes.
Data link connection identifier. DLC. Data link connection identifier. So here I'm going to use, to identify this tunnel endpoint, to go to this end R3, I'm going to use this DLC number. Same interface, serial 1/0. To go to R4, I'm going to use 104. You can decide any number. I'm using 104.
Okay.
Likewise, for R4 to come to R1, I'm going to use 401. For R3 to come to R1, I'm going to use 301. If you want tunnel between these two, you can do, then you need another additional DLC number, let's say 304. And for this end, 403. But in those days, no one was buying a frame relay between R3 and R4. Why? Because it's very costly. So what they will do, no, they will if they want to go to R4 from R3, they'll go to the head office and then they will go to the branch office.
Okay, got it.
They don't want to spend this money. If you spend that money, then it is called full mesh. You remember we learned for full mesh, point to multi-point is a suitable one.
Yes.
Broadcast is not suitable because it is having DR-BDR election.
Yeah.
Sorry, I'm making a mistake. Because there is DR-BDR election in non-broadcast, we can use this full mesh. But in the real world, they didn't buy full mesh, you know. I told you they will avoid this. So it is hub and spoke. You see, this is hub and spoke. Yeah. So what is recommended is the second method, point to multi-point. Why? Because there is no DR-BDR election. Correct?
Yeah.
Fine. So to do all these things, we are going to build a frame relay. I'm not going to put this PVC. I'm going to make it as hub and spoke. Right?
Yes.
And the IP address that you are going to give here, let's say it is 10.0.0.1. This also should be same subnet 10.0.0 maybe 2. Here 10.0.0.3. Because I told you this one is layer 2. Frame relay is layer 2. Even though I have a router, I'm going to convert that router to be a frame relay switch. No, that's not a right word. That will be still router. I'm going to enable additionally a feature so that the router will act as a layer 2 switch. We are going to have both layer 2 and layer 3 on the router, but we are not going to use the layer 3 of router 2. We are going to simply use frame relay of router 2. You got it?
Which means like routing functionality we won't be using.
We will not be
Just
using. If you want to use, you
switching
can use
functionality.
it. But in our scenario, I'm not going to use routing function. I'm going to enable frame relay and I'm going to use only frame relay function. Meaning,
Because all are in same subnet, so just
I need a
forwarding is
switch,
enough,
that's
right?
all. I need a frame
Yeah.
relay switch here. I need a
Frame relay
switch
switching.
that will connect all the frame relay routers. I need a switch. These are frame relay routers, no? We are going to enable frame relay in this end. I told you the serial port by default it will be HDLC or PPP. We are going to remove that and make it as frame relay. So we need a switch to connect all these three frame relay routers. That is what we call it as NBMA network, non-broadcast multi-access network. You understood? Shall we go?
Yeah.
Right.
Yeah.
So we got these routers ready, and
Yeah.
I have named this routers switch 4, switch 3, router 3, router 3, not switch 4, router 4, router 4, router 3, router 2. I named it as frameless switch itself, just a name only. Still, I have not started the frameless configuration. Now let us start, sir. As we discussed,
Okay.
we are going to have 10.0.0.1/24. This is going to be 10.0.0.3. And this is going to be 10.0.0.4. Now, as I said, the PVCs that we are going to use, Del C number 103 and Del C 104. 103 will be connected to the other end, Del C 301, and 104 I'm going to connect it to 401. So this is going to be configured on this port. So which one is 301? This one. And which one is 401? The one which is taking you to between router 4 to router 1. So let us now first finish the frame relay switch part. It will be totally different from what you have learned so far. So manage. The very first command is frame relay switching. This enables the process called frame relay. It enables the support of frame relay. So now the router can act as a frame relay switch. Next, I'm going to interface serial 1/0, and I'm going to say encapsulation frame relay. And then I'm going to say frame relay INTF type DCE. Because it's a switch is a DC device. You need to say this. Whereas this end will be a DTE device.
Yeah.
This will be a DT device. Router is a DT device. This is acting as a frame relay router. This is acting as a frame relay switch. Next.
Yeah.
frame relay route. Data
So
communication
DC
equipment.
means what is the full form? Okay. So S10 is a DC, right?
All the ports of this
That
switch is a
sorry.
DC. Should be configured as a DC. Now
Okay.
on a frame relay switch, I'm in this interface Ethernet serial 1, 1/0, serial 1/0. I'm going to say frame relay route. Del C number is 103, isn't it? 103. Interface means what is the other end of the interface to whom you are going to connect? Serial 1/1. Here, this interface.
Serial one.
You see,
1/.
we are trying to put one tunnel. Like this, isn't it? Another tunnel.
Okay.
So this is 401.
Got it.
This is 104. This is 103. This is 301. That's what I'm trying to do. So I'm saying outgoing interface is serial 1/1, isn't it?
Okay.
Now what is the DLC number of that?
Yes.
301. And you need to say broad.
301.
Not necessary. That's it. So one tunnel, one end is finished. One of the tunnel is finished, isn't it? I'm on which interface? Serial 1/0.
Yeah.
Now I'm going to put another tunnel end on the same interface. Frame relay route. What is the number? 104. Interface serial 1/2.
104 destination S12.
401. Enter.
401.
No shut. Exit. Next. Let's go to the other end. Interface serial 1/1. No shut. Frame encapsulation frame relay. And then frame relay INTF type DCE. Frame relay route 301 interface. Tell me. No, sir. I'm already in 1/1.
S11.
What is the other end? S1/0.
S10.
What is the number on that other end? 103. That's it. Likewise, I need to go
103.
to interface serial 1/2. No shut. Encapsulation frame relay. Frame relay INTF type DCE. Frame relay route. 401. Interface is serial again 1/0. 104. That's all. Now, if you go and check the status of this route, they will all be in down state, inactive state. See, show frame relay route. They're all inactive. This looks active, but it will go down. It will go down soon. The reason is the other end is not up. Which end? Yeah, the router 1, router 3, and router 4.
The other routers. And
still, we have not configured to use encapsulation frame relay. They are all using what? They are all using what? HDLC.
Yes.
Right now. So now, if I go to router 1.
Yes, correct.
And say interface serial 1/0. Let me show you the default first. Wait, let me put the IP address. IP address 10.0.0.1 255.255.255.0. Now let me show you the default encapsulation. Show interface serial 1/0. You see the default encapsulation type is HDLC. I'm going to change it to interface serial 1/0 frame relay encapsulation type frame relay. Done. Likewise, I'll go to interface serial. Okay, that's all. Now, let me show you this show command again. Now, if you go and see, the encapsulation type is frame relay, and the local DLCA number automatically it is generating the local DLCA number for this side. This is LMI type, local management interface type. DLC number is this. LMI type is Cisco. These are all, the protocols used to converse. Now, likewise, I'm going to go to R3, but before that, let's go back to R2. Earlier, these all were inactive, right? But now, you see, these two are active. Now, yeah.
Active,
Oh, no, only 1/0,
right?
both are active.
1/1 and 1.
Here only we finish. Only R1 is finished, no?
Okay.
Let's go to R3 side.
Yes. So that side is active, yes.
Interface serial 1/0, no shad, encapsulation frame relay, IP address is 10.0.0.3, 255.255.250. Done. Next is I'm going to go to R4. Interface serial 1/0, no shad, encapsulation frame relay, IP address is 10.0.0.4. You see, have we ever told about 103, 301, 401 to this router 1 and router 2 and router 4? But you see, show frame relay map command. If you see here, it has learned that 401 which we configured here. Can you see that? Router 4 says, if I want to go to 10.0.0.1, I will use the DLC number 401 as the destination. It is learned dynamically using a protocol called inverse ARP.
Okay, got it.
It's not ARP. ARP
Dynamic,
usually resolves IP address to MAC address, isn't it? But this is inverse ARP. It resolves IP address to DLC number.
Yes. From back to.
All right. Now,
IP address
likewise,
to DLC.
We'll go and check in R1. Show frame relay map. You see, in order to go to 10.0.0.3, I'll use this DLC number. It'll send to 103. 103 has tunnel to 301. It will go out like this. You got it? Now, if I ping 10.0.0.3, I am able to ping. See? So the middle switch is acting as what? As a frame relay switch. Now, if you go to R2, all will be active.
Frame
all
relay
status are active. Okay, now we have got NBMA topology ready. Now on router 1, 3 and 4, we are going to run OSPF. And we are going to test those 5 different type of NBMA types. So
Okay.